the last session, I explained what promises are, and we went over a couple of simple examples showing how they can be created. In this session, we'll go over how to create promises in more detail. We'll cover making promises that resolve and reject, how to handle these promise resolutions, and how to chain promises together. To recap, a promise object is created with a new operator, and a constructor argument is a function that itself has two arguments, which are the resolve and reject callbacks. To add a resolve callback, or fulfillment handler, to this promise, call the then function on a constructed object. You may add as many fulfillment handlers on a promise as you would like. Every callback will be invoked once, either once the promise is resolved or immediately if the promise is already in a resolved state. Now, let's explore promises that fail or are rejected. Just replace the resolve call in the promise definition with reject. The structure is basically identical. It's conventional to have an argument in the reject callback return an error object. We mentioned errors in the default arguments session, but basically they're a type of object that includes information for debugging runtime errors, or runtime exceptions. The new operator before the error constructor is optional and produces the same result. Anyway, if we evaluate this promise, we'll likely see this error appear in the console. There are two ways to handle a promise that moves into a rejected state. One way is to use the then function's optional second argument. Another way is to add a rejection handler to the promise, like this. Just like with the then fulfilled handler, this one is invoked immediately when the promise is already in a rejected state. Did you notice that although the rejection handler was defined on the line after the promise was defined, the console message about the uncaught error did not appear? This is because the JavaScript interpreter always executes handlers on promises asynchronously, immediately after the current thread of execution completes. This is important to note in case handlers on the promise mutate the outside state in some way. You should always assume a promise will be resolved far into the future. Do not make timing assumptions in code. If something relies on the state of a promise, add a handler to the promise. What happens if a then fulfillment handler is added? As you can see, the function defined is not called. The string, will this message appear, does not show up in the console. Instead, the function immediately returns an instance of a rejected promise and displays a uncaught error message again. The fact that calling then returns an instance of a promise plays into promise chaining, which we'll cover shortly. I was just making the point that if a promise is in a rejected state, it will not execute code inside a fulfillment handler. Anyway, the inverse is also true. If a promise is in a resolved state, it will never invoke the rejected handler, or any rejected handler. Promises can also become in a rejected state if a runtime error is thrown in the function defined in the promise constructor. For example, To issue a callback when a promise is either resolved or rejected, use the generated promises finally function. The callback function defined in finally does not take any arguments, because the resolution cannot be determined. Each of these promise functions, then, catch, and finally, all immediately return a reference to another promise object. This allows for a practice known as promise chaining. In JavaScript, function or method chaining is a practice where a function is called on an object that is the output of the function before it, in a chain. For example, it can also be structured. The object returned from a function in a chain can either be a reference to a different object or a reference to the same object. Promises can be chained together in a similar manner. Whatever a function defined in then, catch, or finally returns is fed into the promise resolution after it. Here's a similar example in promise form, without chaining everything into one statement. And here's with chaining them together into one call. Think of the functions defined in the then, catch, and finally calls as promise definitions of their own, except instead of calling resolve or reject functions, they just return the result. But what if, as is often the case, the operation to execute after a promise is also asynchronous? For example, what if you need to read a file and then write it back without blocking the main thread of execution? The solution is to just make a handler return a promise of its own. Here's the same example, using an artificial delay. Each handler immediately returns a new promise that resolves after 500 milliseconds. The chain variable is equal to a promise that is returned in the very last function on the chain, the last then. A promise that might be used internally in the handler is not the promise the function that adds the handler returns. Remember, promise handlers are always executed asynchronously. In summary, promises can have functions defined for handling when the promise is fulfilled, rejected, or either fulfilled or rejected. Because the functions that add callbacks to promises themselves return promises, concise chains of promises can be formed into a single statement. And the functions that handle a promise's resolution or rejection can also be asynchronous by returning a promise.